Our next lesson is about perimeters and area in the coordinate plane, and this goes along with lessons 9 and 10 in Module 4 of Engage New York. In this lesson, we'll hit one CCRSM standard, and that is to use coordinates to compute perimeters of polygons and areas of triangles and rectangles. Let's get started. Lesson 9 is about perimeter and area of triangles in the Cartesian plane, meaning the coordinate plane. We've already talked about perimeters using the distance formula. So we will review that and also talk about two ways to find the area of triangles. Let's start on page 41 of your student materials. In problem 2, we're given two polygons, and we're asked to find the area by decomposing into rectangles and triangles. Now, there are two ways to find areas of polygons and triangles. And sometimes they both work equally well, and sometimes one is easier than the other. So I'll show you both, and I'll allow you to think about which one is better in each problem. So the first way is by decomposing the inside of the shape into rectangles and triangles. So for example, the left one, you can cut it like this, and that gives you a rectangle on the bottom. And we know the area of a rectangle is base times height. The base here is 1, 2, 3, 4. Let me put this below. And the height is 1, and so the area of this rectangle is 4 units. Up here we have a triangle. This is a triangle, and the area of a triangle is 1/2 the base times the height. The base and the height must be perpendicular. This base is also 4 units long, and the height is 2 units tall. So 1/2 of 4 is 2 times 2, which is 4 units. So the total area is what I get by adding the 4 from the rectangle plus the 4 from the triangle, and I get 8 square units. That's one method. Now, I could use that same exact method in question B with this other quadrilateral, but I want to show you the other method. That's the method where you draw a rectangle that is outside of the shape. So I draw a rectangle that fits as nice as possible on the outside of the shape. Now, as a rectangle, I can find the area of the overall shape pretty easily. It's base times height for a rectangle. This base is 1, 2, 3, 4, 5 spaces. And the height is 1, 2, 3, 4, 5, 6, 7, 8 spaces. So this is 40 square units tall. So the area of this rectangle is 40 square units. But the entire rectangle isn't filled up by the quadrilateral. For example, this triangle is not filled up, and the area of a triangle is 1/2 base times height. The base of the triangle is 1, 2, 3, 4, 5, and the height of the triangle is 1, and so I get 2.5 as the area of this triangle. Also, this triangle down here is not filled in, so I find that area as 1/2 base times height. The base of this triangle is is the same as the rectangle, it's 5, and the height is 3, and so I get 7.5 as this triangle. So I simply take the 40, the area of the rectangle, and subtract 2.5 and 7.5, which together makes 10. And so if I subtract 40 minus 2.5 minus 7.5, I get 30 square units. Now, when you're finding areas, sometimes the inside method is easier, and sometimes the outside method is easier. And I'll let you figure out which method is better or easier. Okay, so let me show you one more problem. Here's an example where one method is easier than the other, and I'm in lesson 10 exercise 2 on page 45 of your student materials. We're asked to calculate the area and perimeter of the given quadrilateral using the Shoeless formula, which we didn't talk about. And that's because I like the conceptual drawing the picture more than I like a formula that you may forget in a few weeks or a few months. Okay, so in this one, if you try to begin drawing triangles and rectangles inside, we might start with doing like this triangle, and we run into a problem over here because I can't really draw a triangle very easily because of this angle down here. Because of this down here, it gets kind of complicated. So I don't use that method. I use the other method, the method where I draw the rectangle outside of the shape. If I draw a rectangle outside of the figure as nice as I can, it still isn't that pretty, but it's much easier. Okay, so if I approach it this way, the overall rectangle has an area, it's base times height. The base is 1, 2, 3, 4, 5. And the height is 1, 2, 3, 4, which is 20 square units. Now, the stuff that's not filled in, first of all, this triangle is 1/2 base times height. The base is, I'll call it 1, and the height is 1, 2, 3, 4. So 1/2 of 4 is 2 units. Okay, down here, I also have a triangle, which is 1/2 base times height. The base of the triangle is 5, and the height of the triangle is 1, so I get 2.5 as that area. Now, over here in this top right corner, it looks complicated, but if I simply cut it like this and like this area is 1, and then I can find these two triangles, which is the area is 1/2 base times height, and the base is 1, 2, 3, and the height is 1, and 1/2 of 3 is 1.5. And then I go over here and find the area of this triangle right here, which is 1/2 base times height. The base is 1 and the height is 2, so I get an area of 1. So I know it's complicated, but this is much easier than finding the area inside the shape. Now I subtract from 20 all these other areas. So I subtract the 2 and the 1.5 and the square that's 1 and the triangle that's 1 and the 2.5 other rectangle. So other triangle. So if I take 20 minus 2 minus 1.5 minus 1 minus 1 minus 2.5, I get an area of 12 square units. All right, so you can find areas by either drawing triangles or rectangles inside the shape or outside the shape. Use a method that fits best. Now this problem also asks us to find the perimeter of this quadrilateral. And I like using a version of the Pythagorean Theorem. So I'll start with finding the length of AB. Now, instead of using the distance formula, which can be a little cumbersome, I'm going to look at this right triangle and think about this as a leg that has a length of 1, and this is a length of 5. Now, I can find the length of the hypotenuse C using the Pythagorean Theorem. 1 squared plus, let me actually start, 5 squared plus 1 squared equals C squared, or C is equal to the square root of 5 squared plus 1 squared, which is the square root of 25 plus 1, which is the square root of 26, which I will find a decimal approximation, so it's easier at the end to find a decimal answer of the perimeter. So I get 5.01. Just kidding. I get 5.10 as the length, that length. Now, a shorter method to this is where I simply take the square root of this number squared and this number squared, which is a lot like the distance formula, which is a faster way to do this. So I'll next find the length CB using this triangle, And this is the square root of 1 squared plus 4 squared, because this is 1 and this is, just kidding, it's not 4, it's 2. 2 squared. That's 1 and that's 2 of that right triangle. And using the Pythagorean theorem, you get the square root of 1 squared is 1 and 2 squared is 4. So you get the square root of 5, which the decimal approximation of the square root of 5 is approximately 2.24. Okay, next, DC, I will use this triangle, and this length is the square root of 3 squared plus 1 squared, which is the square root of 9 plus 1, the square root of 10, and the decimal approximation of the square root of 10 is 3.16. And last but not least, I'll find AD using this triangle, and this is the square root of 1 squared plus 1, 2, 3, 4, 4 squared, which is 1. 1 squared is 1. 4 squared is 16. So I get the square root of 17, and the decimal approximation of the square root of 17 is approximately 4.12. And now if I add up all 4 lengths, I get that the perimeter is equal to 14.62 units long. Okay, so you can use that method on almost any triangle or polygon in the coordinate plane by finding the lengths of each side using a version of the Pythagorean theorem and then adding up the lengths. This video is about perimeters and areas in the coordinate plane. Thank you for watching.